I'm so excited to be here. Saying that's supposed to make me less nervous. So we'll start with that. My name's Mihai Cernusca. I'm technically a creative. And what I mean by that is I like to make things. And these days, making things involves writing a lot of code. So that's what I tend to do with my days. One thing you should know about me is when it comes to technology, I've got a 5-year attention span. So I'm a self-taught web developer turned computer animator. This is Sam. Turned iOS developer. And back to web in 2014, in no small part because of React. And I recently started at Whereby, formerly known as Appearin. And we're a small distributed team working on tools to give people the freedom to work from any location. But today I'm here to talk to you about a project that launched earlier this year. And it's while I was working at HyperAct. And HyperAct is a social impact design studio based out of Gowanus, Brooklyn, just down the street from me. And we built this for the Hoover Institution. And they're a public policy research center based out of Stanford University. And the experience is called America Off Balance, and it's a storytelling experience. And we're going to look at sort of the first half of the introduction, which is what we're mainly going to focus on today. So it's like a scrolling experience. I'm going to play some sound so we're not like scrolling in silence.
America is facing a fiscal crisis of epic proportions, one that threatens our country's ability to provide for the next generation. Federal tax revenue collected by the government is at an all-time high, but it's not growing anywhere near fast enough to keep up with what the government spends. This gap between revenue and spending has led to astronomical deficits, adding to the federal debt every year. Right now, the debt is at $15 trillion, and by 2048, it will climb to nearly $100 trillion, which is 50% larger than our entire economy.
Okay, so that was the first half of the introduction. This is the introduction to a fairly sizable project. And it took literally a small village, and I played a small part, and I'm very grateful for the opportunity to make it, help make it a reality. But before we go any further, I want to really establish like what we're actually building. So we're going to look at what it took to build this, but what exactly is it? And I want to ask the question, is it a brochure, for example? Or is it more like a magazine? Or is it actually a presentation? And I would argue that it's neither of those things. I'd argue that what we're actually building is closer to this, which is a digital pop-up book, right? And I find these super fascinating because they're equal parts very technical and equal parts very creative. And the people who build them have a title that's really cool. It's like paper engineers, which I find I'm kind of jealous. But so they're about elaborate transition between pages, between states. So that's very similar to what we're going to be dealing with today. So we'll start there with a bunch of pages. This is kind of what I saw when I joined the project. And I really fixated on these shapes here. Like when I saw this, I was like, how am I going to avoid working really hard to do this? So we're going to start with shape generation and then look at the rest of the animations, and then how do we put this all together, and then really focus on some of the challenges that I faced. So when we're talking about shape generation, I'm really talking about kind of this effect. And after spending a whole 24 hours convincing myself there's no easy way of getting around understanding what I'm trying to do here, I opened up Figma and I drew a circle and a square. And I started moving them around, and then I joined them into one shape. And I chamfered the edges, and I was like, yes, I'm done. I just have to figure out how to do this with code. So, yeah, so we do that. And that search goes nowhere really fast, trust me. So what we actually want to do is we don't want to merge the two shapes. We want to essentially, when our circle and square intersect, we want to draw a new shape on top of it, right? So that's the task. So now it's a lot simpler because we know what we have to do. And we're going to use SVGs because we're using React, and it's obviously markup. Like if you ever opened one, React's pretty good at rendering markup, so I figured it's a safe bet. But the problem is if you have opened one before and you kind of look at this nonsense, it's like, what are we actually talking about? Like, what is this path? So the path is a generic vector object. And when we're talking about dynamic SVGs, what we're talking about is really we want to have a function that generates that nonsense for us, that generates a shape. And we'll just have React sort of render it for us. So we're actually going to jump to the solution, but so by the way, I'm going to have Code Sandbox examples for all these examples. So we're not going to focus on the code too much. It's just like try to visualize what's going on. So that nonsense that we looked at earlier is really domain-specific language. And the way I like to visualize it is if you have a robotic arm with a pencil, and you have to tell that robot how to draw a shape, you'd end up designing a domain-specific language very similar to what SVG has implemented. So you tell the robot to move to the first point, draw a horizontal line to the next point, draw a vertical line up, and so on. The interesting commands that get a bit hairier is like this quadratic curve, which draws a curve with only one control point, or multiple, but it needs at least one. So this is what gives us that smooth effect. So we tell it to draw a curve from here to here through this point, and it just kind of smooths, which is very useful because otherwise you'd have to figure out the points for a lot of these like Bezier handles. And the other hard one is the arch, so this one up here. And that's because with 2 points, you're actually describing up to 4 different arches. So you have to decide between those two. And the trickiest one, I thought, was this large, where it's like, do I want the small arch or the big arch? And that depends on if this angle here goes over 180 or not. So I'm actually flipping that angle flag to 0 and 1 as I'm going. But that leaves us with the question of, OK, we know how to draw the shape, but how do we get the points? And we kind of have to go back to math here. And ideally, if I had to draw my perfect APIs that I want for this, I would represent them like this, which is like we need to intersect 2 circles, and we need to know how to intersect a line in a circle. And that will give us all the points that we need. Luckily, people who actually know what they're doing have open sourced this, and shouts out to William Fissett for having the best bio on GitHub. So this is a really cool repo of a lot of collections of algorithms and math-related things that made my life really easy. So hopefully, given these functions, you could sort of imagine how you would get these points and connect them into the shape. And I used the same effect for the two. These are actually debug views from the real thing. It's a bit more complex because you have 2 circles and they're kind of intersecting and doing resizing and stuff, but it's essentially the same technique. Then I quickly want to talk about dynamic interpolation. So we had all these texts moving up and down. And when I say interpolation, I think it's sometimes confusing because it has a lot of definitions, but I think the core point is that we actually just want to generate a point in a range at a certain % value. So like halfway between 0 and 10. And one way to do that is with an easing curve, which is a function. And it's sort of like a canned effect of the change. Or we could dynamically model the change with a spring, which is an object, so it's a stateful object, as opposed to a canned effect, so it's a simulation. And for this, I chose to use React Spring, which at the time was not fairly well proven, but it turned out really well for me. And the API looks a bit like this. But to help us visualize it, I think sort of like a signal diagram would be a better fit. So in this case, as I'm moving the mouse, I'm setting this immediate flag on the spring itself, which is kind of bypassing React Spring. But as soon as I let go, the simulation takes over. And React Spring is actually animating this for us outside of React. So that's why we're kind of rendering an animated ellipse as opposed to an ellipse. And it does this purely for efficiency. And the only other point I want to make about React is when we look at the API, the hooks API at least, it looks very similar to like the useState hook, for example. And that's a pretty important point because if I was to replace it with a useState, nothing else about the code would change. So really, you don't have to work around React Spring to add animation to your code. It kind of fits in. It just kind of plugs in really nicely. So that's really good. And the last thing I want to touch on here is how do we kind of think about orchestrating this? So let's take a simpler example when we want to sort of transition from the screen on the left to the screen on the right. So we'd have to go through sort of keep breaking it up into something that looks like a spec to get there. And then it's going to be we're going to make the transition with scroll, so we need a way to keep track of the scroll position and get how far are we in the experience. And it'd be really useful to kind of break it up into logical sections so that we don't have to map that giant global progress to the individual sub-animations. So we could define like a steps model and have individual progresses for each, which is just basic math, I think. And then for the first step, we're looking at how are we going to get this circle from there to there. And if I was doing this in After Effects, I would just draw a line, like a path, and like tell the circle to just stick to it, right? And it turns out you can do that in code, which was really cool. The SVG kind of path has a length property, and then you can get a point at a %, which gives us exactly what we need to kind of lock that circle onto it. And that gives you complete creative freedom to do any kind of effects. And in the actual experience, we've got some pretty complex curves, and you'll see the different colors match the different steps. And that turned out really well. And the last piece is this idea of a remap, which I use all the time. And it's really taking a number from one range to a different range. So, for example, in this final piece, we have 4 sub-steps of the second step, right? It'd be really cool to just pass a 0 to 100 progress to each individual animation. And remap is a very simple formula to do that. So we can actually visualize it as, so like the halfway point for a 0 to 25 range mapped to a 0 to 100 range is 50. So with a bit of tweaking, we end up with a pretty nice final result. Okay, the actual challenges. So what didn't go so smooth? And I mean, the honest truth is it worked out fine, right? It was fine. React was fast enough. I was the only developer, so I could make the code as nice as I wanted. But it started off fine. And then after I finished, people actually got their hands on it and started using it. And the designers and the people who actually came up with this, imagined this, found all these issues because, the problem is you can't really spec out such an experience. It's in your head or it's in a Figma document or whatever. You can't really build a spec for this kind of thing. You have to kind of discover it as you're building it and working with the materials. So I'll play this while I'm talking. This is a visualization of all the layers, so you're going to get an idea of the complexity of it. So something began to weigh on me as we're iterating on this, because I made a lot of assumptions. So I took a lot of the best practices that I learned building communication applications or whatever, normal applications. And I took all of those and applied them to this project. So that meant separation of concerns, that meant dry code, that meant all these things that we do day to day. And that makes it really hard to make fundamental structural changes to this. And in the end, the code I ended up with, this is the main orchestration file. Don't judge me. Is this 2,000-line massive combination of all the orchestration logic. Because my decision, or my realization at the end, is that this is not 4 different layers independent of each other, on top of each other, with all these simple animations that we could separate. It was actually one big animation. And I had to ask myself, would I take on a project that was twice as complex as this, about 10 times as complex as this? Could I do this with a team where I'm not the only guy who has to slog through this thing? And the answer was no. But we will want to, it's inevitable that it will kind of push in this interaction axis. We will get more ambitious and try to do more ambitious storytelling experiences with the web. So it won't stop at digital pop-up books. But the complexity rises as you go on the scale, I think. So if we're going to talk about architecture and complexity, I'd like to play you a clip from a talk by Alan Kay that kind of gives us a good metaphor to talk about it.
Again, our common sense is to aggregate things. So when we think about what can we make from bricks, the simple way of aggregating bricks is in a pile or in a kind of a stack. If we make big aggregates that way, we get Egyptian pyramids or big walls. But what we don't get, and what some of the smarter civilization in history, like the Greeks, didn't get, is non-obvious combinations of these bricks, and partly because the powerful idea that there could be non-obvious things hadn't really surfaced yet. So here's a non-obvious way of dealing with bricks, and you can sort of see why it's difficult to invent the notion of an arch, because in order to make an arch, you actually have to make a lot more than is here when you get done. So there's a whole scaffolding that goes in, the bricks are laid on top of it, you drop the keystone in, you put some more bricks around this wall, and then you subtract out the scaffolding and everything stays up and is both light and powerful. So you can make very big structures the size of the pyramid from about 1/millionth the amount of material.
So one of the things Alan Kay is telling us is that it's really normal and easy to try to take something that we know works, a process that we know works, and try to scale it into bigger and bigger, take on bigger and bigger projects with it. So this is a patent this is how Disney imagined computer animation would work. It was just computers controlling puppets, physical puppets. But luckily for us, the web is young, and we have more mature industries to look at, like games. So I'm going to look at a game that was really influential for me growing up, Prince of Persia. And this is a game that was the first that had really cinematic kind of qualities to it, really lifelike animations. It also had impossibly huge levels that I could not wrap my head around how somebody could build them. And it was built by one person, Jordan Mechner. And he gave a talk at GDC in 2016 where he basically outlined how he built this, something that to me, looking up, looks like the size of a pyramid, right? The complexity of it must be insane. So the way he did that is, in 1985, the game was released, but he actually built a visual tool to lay out these levels. Mind you, this was done on an Apple II. There was no lowercase letters, so I have to guess that he was just tired of yelling at the computer. So, and that's why he built a visual tool. But he was really inspired by Alan Kay research on the graphical user interface, which Apple kind of borrowed. So this was probably one of the first examples of a visual editor. And I found that really inspiring. And when I was looking at this, and I was thinking, Alan Kay, okay, I really realized this tool was the scaffolding to this game. He basically built this tool, built a game on top of this system and these rules that he'd built out. And then he just had a way to quickly iterate and try things out. And that's how these massive levels came to be. And he actually credits this tool for saving the game because he had to completely redo the game in the last 2 months. And this tool allowed him to do that. So I want to put a name to this kind of concept that maybe we could use it as a strategy for dealing with some of this complexity. So I'm going to call it visual scaffolding tools. And they have a few properties. They have to be cheap and modular, and they have to be temporary. And the first two, we got a big architectural boost recently with React and hooks. And I think Zach's kind of tweet really captures kind of what I felt about it when I sort of moved and started exploring. And what it did to me, it just made everything cheaper and more modular and by extension, it enables building more specific kind of tools, that are not a huge investment. And the temporary one requires a shift in mindset, because as people who work on products, we're like really bad at like throwing stuff away or like building something that we're only going to use once. We like try to like finesse and maintain things. So I have a rule for you. So if the last 10% is 90% of the work, let's shoot for a solid 85, because that's going to give us the best bang for the buck. So I tried to apply this. I wanted to give you like an actual example of what this would look like. So I had a problem. I had to build this slide deck. I knew the kind of examples I wanted to show you. But I also knew from the experience of building a Markov balance that it was going to be just a giant slog of, it's going to be really hard to change if I want to change anything. So I ended up building a tool. And the tool itself is a React component, of course. And it's organized around chapters, and each chapter has a space, and each space is a view, and it has a bunch of layers, and each layer is a React component. That's not particularly interesting, but when you hit enter, you go into an edit mode, and you do a plus, and you get the list of layers. So now, for each keyframe, I can add a layer to it and basically place it, right? So let's say we want to have this image in the middle. And now, when I flip between the different views, it if it finds the layer if it finds the same layer twice, it basically does a transition, right? I just noticed the transition's a bit funny here, because the green kind of goes away immediately. So I'll just fix that real quick. Send that to the back. Okay, much better. So what I found interesting about building this is it not only changed how I built it, it not just made it faster. Having this tool changed what I built. It made it really possible to play around and like really experiment and discover this new medium I had created for myself. So the tools we use day to day directly influence like what you're going to end up building and how you think about what you're building. So they become really important. And just looking generically at, even if none of these lessons apply to your day-to-day work, I think it's really important that, faced with growing complexity, that we look at ways and we feel empowered to look for ways to change how we work and look for opportunities. And then I hope you'll share it back with everybody. Thank you so much. There's a link with all the examples here.